rapid development of robotics and artificial intelligence, AI, is reshaping not only everyday life, but also the very nature of warfare. As we witness robot dogs sprinting 100 meters in under 10 seconds, humanoid robots rolling off assembly lines by the thousand, and advanced AI drones filling the skies, we must confront a new reality, a world where machines may soon fight wars. With countries like the United States and China engaging in a fierce arms race fueled by these technologies, experts are warning of the potential for a catastrophic global conflict, one that could see fleets of lethal autonomous machines on the battlefield. This scenario, which once seemed like the stuff of science fiction, is now rapidly becoming a reality. The stakes are incredibly high, and the urgency of addressing these advancements cannot be overstated. Experts are particularly focused on China's development of military robots, which many believe could be a game changer in any future global conflict. China's rapid progress in robotics and AI is drawing attention worldwide, and their growing stockpile of robots capable of performing everything from logistical tasks to warfare is becoming a cause for concern. One of the key factors driving this development is the rising tensions between China and Taiwan. As President Xi Jinping allegedly prepares China's military, the People's Liberation Army, PLA, for a potential invasion by 2027, China is increasingly turning to robotics and AI to bolster its military capabilities. The PLA's 100th anniversary marks a symbolic deadline, and many believe that China is preparing for a major military escalation, potentially including a war over Taiwan. To counter this, the United States is also ramping up its military AI research, working to maintain its technological edge in robotics and AI weaponry. But this growing arms race could lead to an outcome that is disastrous for humanity as a whole. A prime example of China's robotic advancements is the introduction of the B2W robot dog, developed by the company Unri. This impressive machine can perform somersaults, climb mountains, and even carry a human on its back for rescue or assault missions. Videos of the B2W have gone viral, particularly one that shows the robot dog bounding over boulders and scaling steep slopes with ease. What makes this robot so dangerous, however, is its potential in combat zones. With wheels on each of its 4 legs, the B2W can move at high speed over rough terrain, making it a formidable opponent in any military context. Imagine a swarm of these robot dogs hunting down enemies, armed with weapons on their backs, an unstoppable force of destruction. But the B2W is far from the only robotic weapon China has been developing. Another robot dog, nicknamed Black Panther 2.0, can run 100 meters in under 10 seconds, potentially outrunning most human sprinters. This robot is the result of research by Jitchin University in collaboration with a startup called Mirror Me. By studying the movement of black panthers and desert rodents, the engineers behind Black Panther 2.0 were able to create a highly efficient machine capable of running at speeds of up to 12.4 miles per hour. The robot's legs are equipped with carbon fiber shins for durability, and its running shoes increase grip by 200%, making it even more adaptable to various terrains. In addition to its incredible speed, Black Panther 2.0 also has AI systems that allow it to adjust its balance and stride, enabling it to adapt to different surfaces and maintain optimal performance. This level of sophistication makes the robot highly effective in both civilian and military applications. In fact, we've already seen glimpses of these robots being used for police work in China, with reports of them scanning for malfunctions in cable tunnels and even assisting with suspect apprehension. These robots are not just futuristic concepts, they are already being deployed in real-world situations. While China has made impressive strides in developing robotic canines, the United States is also working on similar technologies. However, China's speed in mass production and its rapid rollout of these robots are raising alarms. The US military is investing heavily in robotic canines, but China's ability to churn out these machines at scale gives it an advantage in terms of quantity and deployment speed. In addition to robot dogs, humanoid robots are also making waves in China. The robotic startup iBot, for example, launched in early 2023, and by the end of 2024, claimed to have produced nearly 1,000 general-purpose humanoid robots. This achievement surprised many, given that Tesla's humanoid robot, Optimus, has not yet reached the same production levels, with full-scale production not expected until around 2026. AIvsHumanity robots, known as Schwann Robotics, are already being deployed across various industries, from factory lines to logistics centers, where they work alongside humans to test and assemble components. The mass production of humanoid robots is not limited to AIvsHumanity. Other companies in China, such as Pudo Robotics, are also making strides in this area. Pudo's D9 humanoid robot stands 5.57 feet tall, walks upright, and can carry up to 44 pounds. It is designed to perform a range of tasks, including cleaning floors and stocking shelves. Its ability to navigate stairs and maintain balance makes it highly versatile, while its AI-driven multimodal interactions allow it to engage with humans in a way that feels almost natural. These humanoid robots are part of a broader trend in which consumer-facing robotics is becoming more prevalent. At the 2025 Consumer Electronics Show in Las Vegas, Chinese companies showcased a wide range of robots and AI technologies, from quadruped robots to cleaning assistants and industrial solutions. Companies like Huawei and TCL are expanding into AI ecosystems, integrating everything from TVs to AR glasses, while electric vehicle manufacturers are also embracing AI-driven features. As robots become more integrated into daily life, the question arises, what role will they play in the workforce? While some predict that robots will assist in household tasks like folding laundry or serving in restaurants, others warn of the potential for mass unemployment as machines take over jobs traditionally performed by humans. The prospect of robots doing everything from mowing lawns to babysitting children raises both exciting possibilities and serious concerns. But beyond the consumer and industrial applications of robotics, there is a much darker scenario: warfare. As the US and China compete for dominance in AI-driven weapons, the potential for a devastating conflict grows. In a war over Taiwan, experts warn that the sheer scale of autonomous weapons and mass-produced drones could lead to a prolonged and highly destructive conflict. The lessons learned from the war in Ukraine, where drones have caused significant casualties, have not gone unnoticed by China, which is ramping up its production of both consumer drones and military-grade AI weapons. The race to develop the most advanced AI is not just about achieving technological superiority, it is also about gaining control over the future of warfare. While both China and the US are focused on outpacing each other, there are concerns that this competition could lead to a situation where AI-driven systems are making critical decisions on the battlefield, with little oversight or regulation. Moreover, the threat of AI escaping human control looms large. As AI systems become more capable, they may develop their own goals and motives, potentially leading to situations where these systems act in ways that are not aligned with human interests. The development of artificial general intelligence, AGI, could usher in a new era of technology, but it could also create a crisis if these systems are not carefully controlled and aligned with human values. In conclusion, while the potential benefits of advanced AI are vast, ranging from medical breakthroughs to solving climate change, there's a dark side to these technologies. As countries continue to invest heavily in military, AI, and robotics, the possibility of a global arms race with autonomous machines is becoming increasingly likely. To avoid a future where these machines are used in warfare, we must prioritize global cooperation and ensure that AI is developed with safety, ethics, and accountability in mind. The future is filled with both incredible possibilities and terrifying risks, and the choices we make today will determine which path we take. Google's latest AI ambition is a groundbreaking project at DeepMind, building a system capable of simulating the entire physical world. This ambitious initiative, led by Tim Brooks, formerly at OpenAI, aims to create AI models that can replicate real-world physics using multimodal datasets like videos, audio, and robotic sensors. The ultimate goal is to pave the way for artificial general intelligence, AGI, enabling AI to anticipate events in an environment much like humans use physical laws to navigate their lives. This initiative ties into other advanced Google technologies: Gemini, a next-generation language model, VO, a video generation tool, and Genie, a model that generates 3D environments from images. By combining these, Google envisions an AI capable of understanding real-world physics, predicting outcomes, and even creating dynamic, interactive environments. At the core of this effort is the scaling hypothesis, the belief that increasing the data and parameters fed into AI models results in smarter systems. Critics, however, question whether scaling alone is sustainable, citing finite data, environmental concerns, and diminishing returns. Despite these challenges, Google is pressing ahead, as seen in job postings for its new world modeling team. Roles like research engineer, world modeling focus on scaling multimodal AI to its limits, emphasizing large-scale training and real-time interactive simulations. The potential applications for such advanced AI systems are vast. In robotics, for example, AI-powered physics simulators could allow robots to train in virtual environments before operating in the real world, saving time, money, and resources. Video games could also benefit, offering hyper-realistic environments powered by AI-trained physics. Beyond entertainment, these systems could revolutionize scientific research, enabling precise simulations of weather patterns, disease spread, and other complex phenomena. AI could even enhance real-time interactions by understanding physical contexts, environments, and human behavior, making it an invaluable tool in industries like healthcare, education, and customer service. Rumors are also swirling about a major update to Google's Gemini model, dubbed Gemini 2.0, which is expected to launch soon. This update may feature flash thinking, enabling quicker decision-making and more dynamic reasoning. If integrated with tools like Genie and Vo, these capabilities could significantly advance real-time simulations and decision-making processes, further enhancing the world modeling initiative. On the enterprise side, Google is making its AI tools more accessible by integrating them into its workspace subscriptions. Previously, AI features like auto-generated spreadsheets, meeting summaries, and video editing required an additional $20 per user. Now, these are included in a slightly increased subscription fee, making AI tools available to more businesses. This aligns with a similar move by Microsoft, which recently launched a free version of its Copilot AI for Microsoft 365, demonstrating the intensifying AI competition between the tech giants. By lowering barriers to entry, both companies aim to gather more users, refine their models, and establish dominance in the AI landscape. Building a system capable of simulating the entire physical world is no small feat. The task requires immense computational resources and innovative solutions to overcome challenges like accurately modeling complex physical laws. Google is adopting a streamlined approach inspired by the bitter lesson, a principle in AI research that favors simple methods capable of scaling effectively over intricate, hand-engineered solutions. This philosophy enables Google to prioritize scalability and performance while minimizing bottlenecks. However, this endeavor raises ethical concerns. Simulating the real world could lead to privacy issues, misuse and surveillance, or unintended societal consequences. Moreover, the environmental impact of training such massive models is significant. Addressing these challenges will require interdisciplinary collaboration and responsible AI practices. Despite the hurdles, the potential impact of this technology is profound. AI-driven simulations could transform industries, making processes safer, cheaper, and more efficient. For example, researchers could model viruses spread or experiment with new materials virtually. In entertainment, game developers could create immersive worlds with unparalleled realism. And in everyday life, AI could enhance tools like virtual assistants, enabling them to understand physical environments and respond with greater accuracy. As Google and its competitors like Microsoft push the boundaries of AI, the race toward AGI is heating up. The introduction of systems capable of simulating the physical world could represent a significant step toward this goal. However, whether this marks the dawn of a new era in AI or remains an ambitious experiment depends on overcoming technical, ethical, and resource challenges. What do you think about Google's ambitious world modeling project and its implications for the future of AI?